The origin of species struck the Victorian solar plexus like a steam hammer. The world of the mind would never be the same again, neither science nor anthropology, psychology, sociology, even, and here we come close to the dark side, politics. This book, which Darwin always described as the abstract of the great book that he intended to write but never completed, achieved what the 1858 papers did not. It isn't just that the origin explained the theory more clearly than Darwin's and indeed Wallace's brief offerings of 1858. The real difference was that a book-length treatment was required to muster all the evidence and lay it out for all to see, one long argument, as Darwin himself called it. And I quoted before Darwin's own recognition when the joint papers of 1858 fell flat that this shows how necessary it is that any new view should be explained at considerable length in order to arouse public attention. And is there a fifth bridge which Darwin himself never crossed? Inevitably, 150 years later, there are several, but the one I shall single out is the bridge to the so-called neo-Darwinism of the modern synthesis. I shall rename neo-Darwinism digital Darwinism. There may be other things more neo than the neo-Darwinian modern synthesis of the 1930s, but digital Darwinism is here to stay. The essence of Mendelian genetics is that it is digital. Mendelian genes are all or none, they don't blend. Genes are things you can count in a population's gene pool. Evolution consists of changing frequencies of discrete, digital, countable entities, not changing quantities of substances or changing measurements of dimensions. Changing quantities and measurements apply at the organism level, but not at the gene level. What happens in natural selection is that successful genes become more frequent in the gene pool and unsuccessful genes less frequent. Frequent as in counted. Darwin never crossed the digital bridge. If he had, he would have had a ready answer to Fleming Jenkin, the Scottish engineer who, independently of his colleague Lord Kelvin, his colleague, he collaborated on laying the transatlantic cable, gave Darwin a hard time over matters of theory. As is now well known, Jenkin pointed out that if inheritance were blending, as everybody except Mendel assumed, natural selection couldn't work because there wouldn't be enough variation. As a matter of fact, any fool could have seen that Jenkin's premise must be wrong. Variation clearly does not dissolve away as the generations go by. If it did, we'd all be more similar to each other than our grandparents were. R.A. Fisher, J.B.S. Haldane, and Sewell Wright buried Fleming Jenkin. If genes are countable digital entities that don't blend, their frequencies have no inherent tendency to change. If they do change, that's evolution, and it happens for a reason. The most interesting reason is non-random selection, but random drift also occurs. In the light of the Watson-Crick revolution, we can now see that the very genes themselves, within themselves, as digitally coded messages, are digital in exactly the same sense as Mendel saw with respect to whole genes. I'm talking about the distinction between selection as a negative force and selection as a positive, constructive force that puts together complex new, quote, designs. My own preferred way, the selfish gene way of explaining this, is again to deploy digital genes. So perhaps we really have to cross Bridge 5 in order to paint the full picture. In modern genetic terms, not Darwin's own, natural selection may be defined as the non-random survival of randomly varying coded instructions for how to survive. We see and admire the products, the phenotypes of the good ones. The instructions are DNA, and the most visible products are bodies that survive by doing something impressive, flying, swimming, running, digging, or climbing, all in the service of reproduction, which means they also tend to be good at attracting a mate and warding off rivals. An important part of the environment that each gene must exploit, if it's to ensure its survival in the form of copies of itself, is the other genes it encounters in the genomes of a succession of bodies, which, because of sexual reproduction, means the other genes in the gene pool of the species. As a result, cartels of mutually supportive genes cooperate to build bodies that specialize in some particular method of surviving, such as grazing or hunting. Different cartels are the gene pools of different species, bound together by the remarkable phenomenon of sexual recombination, and separated from all other cartels, for it's part of the definition of species that they can't interbreed. Occasionally, often through accidents of geography, gene pools find themselves subdivided for long enough to become sexually incompatible, and the subdivisions are then free to go their separate evolutionary ways as distinct species. Eventually, separate ways can mean very separate indeed, for animals as different as vertebrates and mollusks originally split apart as members of the same one species. Successive branchings of this kind have given rise to hundreds of millions of species over thousands of millions of years. At least in sexually reproducing species, evolution consists of changes in gene frequencies in gene pools. Each individual genome is like a shuffled pack of cards. The available cards to be shuffled are sampled from the gene pool. The species gene pool is a database which becomes a storehouse of information about the environments of the past, environments in which ancestors survived and passed on the genes that helped them to do so. To the extent that present and future environments resemble those of the past, and mostly they do, this genetic book of the dead will turn out to be a useful manual for survival in the present and future. The repository of that information will at any one moment reside in individual bodies, but in the longer term, where reproduction is sexual and DNA is shuffled from body to body, the database of survival instructions will be the gene pool of a species. Each individual's genome in any one generation will be a sample from the species database. Different species will have different databases because of their different ancestral worlds. Like sand bluffs carved into fantastic shapes by the desert winds, the database in the gene pool of camels will encode information about deserts and how to survive in them. The DNA in mole gene pools will contain instructions and hints for survival in dark, moist soil. The DNA in predator gene pools will increasingly contain information about prey animals, their evasive tricks, and how to outsmart them. The DNA in prey gene pools will come to contain information about predators and how to dodge and outrun them. The DNA in all gene pools contains information about parasites and how to resist their pernicious invasions. Natural selection carves and whittles gene pools into shape, working away through geological time. It's an image that might have seemed strange to Darwin, but I think he would have come to love it. Thank you very much.